I hope screen is visible to everyone.
Yes, ma'am.
So in last class we have started our first unit, that is matrices, and we have discussed what is matrix and type of matrices, and then we are at elementary row operations, right? Operation that can be performed on a matrix. We do have three types of operations. First is interchange of any two rows represented by this. And then second is you can multiply any row with a non-zero constant. Add elements of one row to corresponding element of another row denoted by this, right? If I'm taking one matrix, 1, 1, 1, 2, 2, 1, 3, 1, 3. Randomly, I have taken this one matrix and I'm applying first operation row Ri interchange Rj. So I'm writing here R1 interchange with R2. So how you will write it? Put this sign, that is equal sign of equivalent matrix, and output will be R1 become R2 and R2 would become R1. So you will writing 2, 2, 1, 1, 1 and 1. Then 3, 1 and 3. Now next operation I'm writing R2 implies 2 times of R2. You are multiplying every element of R2 with 2. So that would be equivalent to, now we'll be multiplying in this matrix row 2, that is 1, 1, 1, you'll multiplying every element with 2. So output would be 2, 2, 1. It's 2, 2 and 2, 3, 1, 3. Right? And then last operation, I'm doing it randomly just to show you how you will write it. Now I'm writing R1 implies R1 minus 2 times of R2. Please keep in mind, when you are changing the row 1, then this row 1 will remain as it is, and then plus minus whatever you want to do it like this. You will multiply another row with any constant, but when you are changing this row, you will write it here as it is with coefficient 1 only, right? So answer would be R1 is changing, R1 minus 2 times of R2. So this R1 element entry is 2 minus 2 times of R2. So it means R1 is 2 minus of 2, corresponding entry of R2 is 2. So 2 minus 4, that would be minus 2. Similarly, next, same entry, so it would be minus 2. And then 1 minus 2 times of entry of second row, that is 2. So 1 minus 4, that would be minus of 3. And then 2 as it is, 2 as it is, 2 as it is, 3, 1 and 3. Right? So this is how you can apply operation on a matrix. This is the interchange of rows when you are multiplying elements of row with particular constant and adding one row to corresponding element of another row. That would be represented as this, and how you will write it, I have shown you. Now, equivalent matrices, I have told you all these are equivalent matrices. The matrices which are obtained by applying these elementary row operation, those are known as equivalent matrices. And we represent with this symbol. Now, it was a task given to you, convert into upper triangular matrix using row operation. So how you will convert in upper triangular matrix? Upper triangular matrix means you need to convert these entries into 0. This is your main diagonal, and entries or elements below this main diagonal must be 0 in upper triangular matrix, right? So my first task is I need to make this 0 and this 0, right? So what you will write, what operation you will write here? I need to change R2. R2 implies I will keep this R2 as it is. I need to make this 0, right? So I'm taking the help of first row. फर्स्ट रो को क्या करें, हम किससे मल्टीप्लाई करें सो दैट इट वुड बिकम 0? So we will multiply this first row with 2 so that it become 0. So I'm writing here minus 2 times of R1. Similarly, I need to make this entry also 0, right? So I'm writing here 12 and I'm making this 0 with the help of R1 again. So this 4. So what constant I use? 3. 3 2s are 3 4s are 12, 12 minus 12, 0. So I'm writing here R3 implies R3, you need to keep it as it is, minus 3 times of R1. That is equivalent to, now you will write your results of these row operation. So first row will remain as it is, 4, 2, 3. Right? Now, next. Now you need to change the all elements of row 2. So first entry would be what? Tell me. This entry would be
0.
0.
0.
0. Right now? It is 0. 8 minus 2 times of 4, 0. Next entry. This
Ma'am,
is,
1.
yes, 5 minus 2 into 2. 5 minus 4 is 1. Next entry.
Ma'am, minus 4.
Sorry, beta.
Ma'am, minus 4.
Minus
4.
4. Okay. So this is your R2. R2 entry is 2 minus 2 into 3. So 2 minus 6. That is minus 4. Now come to the row 3. This entry would be 0. 12 minus 4 into 3, 0. Now what is this entry? Minus 4 R3 minus 3 of R1, that is 2. So it is what? Minus 6 minus 4, that would be minus of 10. Now what is next? 5 minus 3 times of 3. So 5 minus 9 is minus 4. Is it clear?
Yes, ma'am.
Now next, this entry 0, this entry 0. Now next target is make this entry 0. So while making this 0, keep in mind after making these two zeros, we will never use R1. We will never touch R1 because if you touch this R1, then these zeros will spoil. Right? So when you are making these two zeros, then don't touch R1, don't use R1 in any operation. Now next target is I need to make this 0. So for making this 0, I will take the help of this row, that is R2. So I'm writing now R3 implies R3 as it is. Okay? Whatever row you are changing, you will keep it as it is. Then plus 10 times of R2. So what it would become now? 4, 2, 3, 0, 1, minus 4, and then 0. Now it would become 0, minus 10 plus 10, 0. And now what would be this entry?
Ma'am, minus 44.
Minus
44.
44.
4.
Okay, you are putting this R3 entry over here, minus 4 plus 10 into minus 4. Why I'm doing so, beta? You can do it, right? Those who are getting confused or those who make mistakes while calculating, that is why I'm writing. This is how you can write in your rough side, right? And then you are getting it as minus 4. So this become your upper triangular matrix using elementary row transformation, right? I hope many of you have done this already. Now come to next, submatrix. What is submatrix? Submatrix of a matrix A is any matrix which is obtained from given matrix by deleting some rows and columns of that matrix. For example, if I'm having a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So you need to find out submatrix of this matrix. So you can make many of submatrix by deleting either this row or this column. So I can write here 4, 5, 7, 8. Or you can write, you can delete this column and this row. So what is left? 2, 3, 6, 9, and so on. Likewise, you can make submatrix by deleting either of any row and column. Now, next is rank of a matrix. A matrix A, not necessarily square matrix, is of rank R if it contains at least one square submatrix of order R cross R. At least, ज़्यादा कितने भी हो सकते हैं? At least one square submatrix of order R cross R with non-zero determinant. But no square submatrix of order larger than R cross R with non-zero determinant. If you are having a matrix A, right? And I need to find out a rank of a matrix. A rank is just like a number. Like you find the determinant of a matrix, so you get a value. So similarly, rank is also a value. So rank of a matrix is R. If I'm saying this is a matrix of order 3 cross 3, and I'm saying that rank of this matrix is 2, right? Just for understanding, if I'm writing here R, instead of R, I'm writing here 2. It means in this matrix or this matrix contains a square submatrix of this order. This order means 2 cross 2. It means there must be one matrix of order 2 cross 2 whose determinant is, let us say I am representing with A dash, and determinant of A dash is not equal to 0, right? And along with this, submatrix of higher order means अब submatrix तो एक ही बनेगी, कितने order की? 3 cross 3 की, तो determinant of that matrix must be 0. If it is so, then you can say that the given matrix has a rank 2. Or if I'm saying another example, if I'm saying the rank of this given matrix is 1, it means in this matrix is having A dash with one non-zero entry. This is non-zero entry and its order is 1. So its determinant is also non-zero. That is fine. But along with this, submatrix of order 2 cross 2, right? And determinant of that matrix must be 0, as well as A double dash, let's say its order is 3 cross 3, it must be 0. Getting my point? If you are saying the rank of a matrix is 1, it means it is having at least one submatrix of order 1 with non-zero determinant. Along with that, all higher order submetrics with zero determinant, right? In this definition I have written here no, right? कोई भी स्क्वायर मैट्रिक्स नहीं होनी चाहिए जिसका डिटर्मिनेंट नॉन जीरो हो. तो इट मीन्स इफ यू आर हैविंग ए रैंक 2, it means your matrix is having one submatrix of order 2 cross 2 with non-zero determinant, at least one. एक होनी चाहिए, एक से ज्यादा जितनी मर्जी हो, it's hardly matter. Is this definition clear? Yes or no?
मैम रिपीट कर दो प्लीज दोनों, सब मैट्रिक्स एंड रैंक ऑफ मैट्रिक्स.
Submatrix is a normal matrix, beta. You can obtain submatrix from the given matrix by deleting any row or any column. देखो, this is your given matrix. I need to make it submatrix. तो मैंने क्या किया, ये रो और ये कॉलम डिलीट कर दिया. ठीक है, what is left 4 5 7 8. तो I made this submatrix. राइट? अब आदित्य कहता है कि मुझे ये रो नहीं डिलीट करनी है, मुझे फर्स्ट रो डिलीट करनी है और मिडिल कॉलम डिलीट करना है. हार्डली मैटर. 2 3 6 9 जो बच गया वो आपने यहाँ लिख दिया. दिस इज अगेन ए सब मैट्रिक्स ऑफ 2 क्रॉस 2. अब किसी ने बोला कि नहीं मुझे तो लास्ट रो नहीं चाहिए, मुझे ऊपर वाले चाहिए, तो लेट इट बी. तो आपने क्या किया, ये वाली रो डिलीट कर दी, सॉरी ये कॉलम और ये डिलीट कर दिया. सो यू आर लेफ्ट विद 1 2 4 5. दिस इज हाउ यू राइट सब मैट्रिक्स. ठीक है, you can delete any row or any column, no issues. Now what is rank of a matrix? Rank of a matrix is a value. Suppose I am having a matrix A, 1 2 2 3. ठीक है, let us start with the starting. Find its determinant. जल्दी से इसका डिटर्मिनेंट बता दो क्या होगा.
-1.
Minus 1.
-1.
Minus 1. Okay. Determinant of this matrix is -1, which is not equal to 0. Right? तो मैं डायरेक्टली बोलूंगी कि इस rank is represented by the symbol row. Rank of a matrix is equal to 2. ठीक है, determinant of this matrix is not equal to 0, तो डायरेक्टली लिख देंगे हम rank of this matrix is 2. Every matrix is a sub matrix of itself. As it is matrix चलती है मेरे पास, ये इसका सब मैट्रिक्स भी लोगे तो as it is रहेगा. अभी देखो, अब मैंने लिया 3 क्रॉस 3 का कोई मैट्रिक्स ले लिया, लेट्स से 1 1 1 2 2 2 3 3. Find its determinant.
Ma'am, it will be 0.
It would be 0. तो हमने क्या किया, इसका डिटर्मिनेंट आ गया 0. ठीक है, इफ इट इज 0 तो इट मीन्स रैंक ऑफ दिस मैट्रिक्स कैन नॉट इक्वल टू 3. ठीक है, बिकॉज ऑर्डर इज गिविंग द रैंक, राइट? ए सब मैट्रिक्स ऑफ ऑर्डर दिस विद नॉन जीरो डिटर्मिनेंट. जैसे ही आपके पास 3 क्रॉस 3 का मैट्रिक्स था, आपने इसका डिटर्मिनेंट निकाला, दैट इज 0. इट मीन्स इट इज श्योर इसका रैंक 3 नहीं हो सकता. इट मे बी 2 और इट मे बी 1. राइट? नाउ फॉर 2 यू आर टेकिंग इट सब मैट्रिक्स. आई एम टेकिंग सब मैट्रिक्स 1 1 2 2. और किसी बच्चे ने लिया 1 1 3 3. और किसी बच्चे ने लिया 2 2 3 3. ठीक है, नाउ you can have many submatrix. Now you need to check if you are getting at least one of submatrix of order 2 cross 2. मतलब इनमें से कोई एक अगर ऐसी मैट्रिक्स मिल जाती है जिसका डिटर्मिनेंट क्या हो जाए, नॉन जीरो हो जाए, कोई भी एक मिल जाए, उसका डिटर्मिनेंट अगर नॉन जीरो हो जाता है, देन यू कैन श्योरली से दैट इसका रैंक क्या हो जाएगा, दैट वुड बी 2. ठीक है, बट जितने सब मैट्रिक्स आप बना रहे हो, लेट्स से सबका डिटर्मिनेंट 0 आ जाता है, यू आर नॉट गेटिंग इवन ए सिंगल सब मैट्रिक्स विद डिटर्मिनेंट 0. You are not getting even a single matrix with non-zero determinant. Every matrix is having determinant as 0. So you can say that rank of this matrix cannot equal to 2. So ultimately what is left? Only 1. So rank of a matrix would be 1. बिकॉज वन ऑर्डर का सब मैट्रिक्स तो क्या हुआ वन हुआ ना तो इसका डिटर्मिनेंट भी वन हुआ या फिर यू विल कंसिडर टू then again its determinant would be non-zero. So out of this matrix, if you are considering 3 cross 3 matrix, determinant of that matrix would be 0. If it is 0, it means rank cannot equal to 3. Then you have considered lower order 3 से 2 पे आए 2 cross 2 के सारे सब मैट्रिक्स बनाए. If you are getting determinant of all submatrix of order 2 cross 2 is 0, it means its rank cannot equal to 2. तो क्या बचा? Rank would be 1. ठीक है, बिकॉज इट इज ए नॉन जीरो मैट्रिक्स. अब नाउ माय क्वेश्चन इज कि अभी तो हमारा क्वेश्चन 3 क्रॉस 3 का था, तो इट इज वेरी इजी टू फाइंड आउट डिटर्मिनेंट ऑफ 3 क्रॉस 3 मैट्रिक्स और 2 क्रॉस 2 मैट्रिक्स और 1 क्रॉस 1 मैट्रिक्स. ठीक है, बट व्हेन इट्स ऑर्डर बिकम हायर देन it would be difficult to find the determinant at every step. So that is why we do have one method how to find rank of a matrix. But before proceeding to the how to find the rank of matrix, let me know whether this definition is clear or not.
Yes, ma'am.
If anybody is having any doubt, still having any doubt, then when we will solve the question, you can ask your query, right? Now, in short, rank is order of largest non-zero minor of A. Rank is the order of largest non-zero minor of A. And you find the minor how? How you find the minor? Deleting that row and column and corresponding जो elements बच जाते हैं वहां से आप उनका determinant निकाल लेते हो, right? Rank of a matrix is represented by the symbol row of A, or directly write rank of matrix A. Now, next is row echelon form. This is your row echelon form. The goal in for finding the rank of a matrix, my first task is convert given matrix into row echelon form. First target, right? ये मेरा target है, ये मेरा goal है. I need to make row echelon form. In row echelon form, first entry should be non-zero, and then after that कॉलम वाइज ऑल वुड बी जीरो. जितनी भी रोज हैं आपके पास इस तरह से कॉलम में रीड करेंगे, जितनी भी रोज नीचे आती हैं उन सब की फर्स्ट एंट्री क्या होगी? दैट वुड बी जीरो. सो लेट अस से यू आर हैविंग 4 क्रॉस 4 मैट्रिक्स, तो इन फर्स्ट रो यू विल बी हैविंग 3 0. देन दिस नंबर ऑफ जीरो वुड डिक्रीज along दिस कॉलम वाइज. यहाँ 3 है तो यहाँ 0 होगा और फिर यहाँ 0 हो जाएगा. You need to create such type of a matrix, and this type of form is known as row echelon form. You need to create 0. If you will counting it row wise, then number of 0 would be in increasing order. Number of 0 would be in increasing order while we move downward and we read it along row wise. This row 1 0, next row 2 0, next row 3 0. If next would be there, then there would be 4 0. And 0 row, what is 0 row? When every entry in that row would be 0. 0 row always lies at the bottom of matrix in row echelon form. We use elementary row operation to make matrix look like the one given below, right? This sign just means there can be any number here. We don't care. We care about these value. These value must be 0, right? Steps to find the rank: reduce the given matrix to an row echelon form and then count number of non-zero rows. That count gives us the rank of that matrix. If all entries of a matrix in a row, if all entries of a row in this matrix are 0, then only it is a 0 row. If you are having like this 0 1 0, then it is non-zero row. If all entries would be zero, then only it would be a zero row, otherwise it is non-zero row. ये भी non-zero है, ये भी non-zero है, and if all are 1 1 1, it is again non-zero. This is only zero row. You need to count number of non-zero rows. If you are having such type of row in your matrix 0 0 0, so it is a zero row. You will not count it. You will count this, you will count this, and you will count this. Right? Let us have example. Find rank of each of the following matrix. First matrix is this 1 2 3 5. If normally I'm asking find the rank of this matrix, then if definition of rank is clear to everyone, then you can tell me what is the rank of this matrix. Let us say this is equal to A. Now my question goes to you. Tell me the answer. Rank I represent with the symbol this. Now tell me, what is the rank of this matrix?
Ma'am, 2.
2.
Apply the given definition, just given definition. Because it is a small matrix, you can apply the definition. Yes, tell me.
2, ma'am.
2. Who said 2 beta? What is your name, bache?
Ma'am, Nitesh.
Nitesh. Why 2 beta? Why you said ki rank of this matrix is 2?
जब हमने सॉल्व किया तो जो नॉन जीरो रोज और रोज है वो 0 है.
Okay, it means you have converted into row echelon form?
Yes, ma'am.
Okay, means you made here 0.
Yes, ma'am.
Okay. Any other?
मैम डिटर्मिनेंट नॉन जीरो है.
किसने बोला है बेटा? क्या नाम है आपका?
मैं सात्विक.
सॉरी बेटा?
मैं सात्विक.
कार्तिक.
मैम एस सात्विक.
Karnik. Okay, beta. Very good. Both are correct because it is a very small matrix. So I can find out its determinant, and I am finding its determinant. Its determinant is -1. That is not equal to 0. तो डायरेक्टली मैं कहती हूँ जितना इसका ऑर्डर है वही इसका रैंक हो जाएगा. सो यू विल राइट रैंक इज इक्वल टू ऑर्डर ऑफ मैट्रिक्स इज इक्वल टू 2 इन केस ऑफ definition. When you are talking about the determinant, non-zero determinant, then we give the rank of a matrix with order of that matrix. ठीक है, अभी बिकॉज बहुत छोटा सा था मैट्रिक्स तो मैंने सीधा डिटर्मिनेंट निकाला और मैंने फाइंड आउट कर दिया. अदरवाइज आप क्या कर सकते हो, इसको रो एक्लेन में कन्वर्ट कर सकते हो. रो एक्लेन से क्या होगा, यहाँ 0 बन जाएगा आपके पास, एंड इफ यू आर गेटिंग हियर 0 बट इट वुड बिकम नॉन जीरो, तो आपके पास नॉन जीरो रोज 2 हो जाएंगी एंड रैंक ऑफ दैट मैट्रिक्स वुड बी 2. Now, matrix is this 1 minus 2 8, 2 minus 4 16. Find rank of this matrix. Find rank of this matrix. Just tell me one thing.
Ma'am, 1.
Rank is 1. Okay,
1.
beta. Now you tell me, can I say that rank of this matrix is 3? क्या 3 हो सकता है in any case?
No, ma'am.
No. Why not?
Because it's an 2 cross 3 matrix and we can't make it a square matrix of 3 cross 3.
Right. Right now, we cannot find the determinant because it is a rectangular matrix. 2 rows, 3 column. तो मैक्सिमम यहाँ से जो आप स्क्वायर मैट्रिक्स निकाल सकते हो उसका ऑर्डर क्या होगा, 2, है ना. तो डिटर्मिनेंट इसका रैंक 3 तो हो नहीं सकता. अभी रैंक क्या होगा, या तो 2 या फिर 1 होगा. तो अभी किसी बच्चे ने मुझे बता दिया है कि इसका रैंक क्या है, 1 है. जिसने भी बताया बेटा कैसे सॉल्व किया है, यूजिंग
Echelon form.
Echelon form. So let us do with the echelon form. In echelon form, what is the echelon form? This entry must be non-zero, and after that you need to create number of zeros in increasing order. Right? So my first task is you need to make this 0. So for this you will applying operation R2 implies R2 minus 2 times of R1, right? And that is equivalent to 1 minus 2, 8, 2 minus 2, 0. For this, R2 is minus 4, minus 2, and then minus 2. Minus 4 plus 4, it is 0. And then again, 16 minus 2 into 8, 16 minus 16, it is 0. You have converted this into row echelon form, right? After converting the row echelon form, you need to count number of non-zero rows. This row is completely 0, so only having one non-zero row, right? So you will write rank of a matrix is equal to number of non-zero row, and that is equal to 1. So rank of this matrix is equal to 1. Is it clear? Right? So because it is very difficult to find the determinant of 4 cross 4 matrix, right? And in that case, first of all, we need to check 4 cross 4. फिर उसके बाद कितने सारे सब मैट्रिक्स बनेंगे of order 3 cross 3, right? So it would become very laborious. So that is why we do have one method: convert given matrix into row echelon form and then find the number of non-zero rows, right? This is how you find the rank of given matrix. And order of this matrix is what? 2 cross 3, right? 2 rows, 3 column. So rank of it, this is a rectangular matrix. So it is sure that rank of matrix is less than equal to number of rows in a rectangular matrix. Is it right? Can we conclude that if you are having a rectangular matrix of order m cross n, m number of rows and n number of columns, the rank of a matrix can be less than or equal to number of rows of that given matrix. Right?
Yes,
Now,
ma'am.
next, find the rank of this matrix. So again, we will do row echelon form. I'm giving you 1 minute ना. जल्दी से अपनी notebook में solve करो. Take 1 minute and convert it into row echelon form using elementary row transformation. My goal is making this entry 0, this entry 0, as well as this entry 0. While making these entries 0, और अगर और entries भी 0 बन जाती हैं, it's hardly matter.
Ma'am, it's 3. Power is 3.
Rank is 3.
Yeah, ma'am.
You have calculated its determinant.
Yeah, ma'am. No, ma'am. By row echelon form.
Row echelon form. Okay. So let us see. Answer is 2 beta. Okay. Now let us check. I need to make this 0 as well as this 0. So for making this 0, I will applying this operation. R2 implies R2 minus 2 times of R1. Right? For making this 0, again I'm taking the help of R1. R3 implies R3 minus 3 times of R1. Keep in mind, beta, this entry is 1. So it would be easy to make this 0 and this 0 with the help of R1. Right? Every time we will try to make this entry and this entry 0, we will always use R1. Right? You can do it one by one because you are doing it first time for finding a rank only. Okay? Otherwise, though, you have done so many operations in matrices. So if you are not comfortable with 2, you can do it one by one. Otherwise, we applying these 2 operations, and that is equivalent to what? 1, 2, 3. right? Second row, 2 minus 2 is 0. Now this entry is 4, R2 is 4 minus 2 into 2. 4 minus 4, again 0. Next entry is 7. 7 minus 2 into 3. 7 minus 6 is 1, right? Now corresponding to this, R3. 3 minus 3, it is 0. 6 minus 6 minus 3 times of 2. 6 minus 6 again 0. And next entry 10 minus 3 into 3. So it is 1. Is it right, beta? But now you can create more zero because number of zeros must be in increasing order. Abhi kya hai? Both are same. And you can create one more zero over here. I think you have done this, beta. Who has given me the answer?
Yes, ma'am.
Shubham. You did like this way, beta?
Yeah, ma'am, but I forgot to at the last step.
Yes, है ना?
Yes.
Number of zeros must be in increasing order because both rows are same. So you can apply
Yes, ma'am.
one more operation. R3 implies R3 minus R2. So that would be equivalent to 1, 2, 3, 0, 0, 1, 0, 0 and 0. So now you will count because now it is in echelon form. Number of zeros are in increasing order. So now count the number of non-zero row. This is one row and this is another row. So rank of this matrix, let us say this is given matrix as A, that is equal to 2. This is given matrix A. Is it clear?
Excuse me,
Yes,
ma'am.
ma'am.
Yes, ma'am.
You need to convert given matrix into row echelon form. Row echelon form means first entry should be non-zero and then you need to create the number of zeros in increasing order while we move downwards. After creating number of zero or creating or converting into row echelon form, you need to count number of non-zero rows. That gives you rank of given matrix. Now note it down, beta. It's your homework. Find the rank of this matrix. Noted? Leave this. I'll show you some more question. You need to solve it. Note it down, beta. Find the rank of following matrices. Answer is given to you, but you need to solve it in your notebooks. Complete. Right? So that's all for today.